Welcome back to Methods Unit 1 and 2 with Mr. Hanna. This video, we're going to be looking at graphing quadratics, and I'm going to split this into several videos because it's a fairly large topic. So this first part, we're going to be looking at different quadratic forms and also the features of a parabola. So let's start by graphing a parabola and having a look at the different features of the parabola. So let's graph a parabola that is x squared, just x squared, so the most basic parabola. Okay, so what can we see? First, we can see its general shape. It's a sort of a smiley face looking shape. We can see the turning point down here, the turning point. That's also a point of symmetry, so it's symmetrical around the turning point. What else can we see? We can see that it touches the x-axis there. Alright, let's plot another parabola and see if there's any different features with this one. So let's start with our x squared that we had before and then go minus 5. Minus 5. Okay, so similar features. It's still a big smiley face. Still got a turning point. Now we've also got some x-axis intercepts, and it's more noticeable now that we've also got a y-axis intercept. So I've got a turning point, x-intercepts, y-intercept, and it's still sort of a smiley face. Alright, let's plot one more, another parabola. Let's go with negative 3x squared plus 2x. Let's check that out. Okay, there we go. So now what we've got is it's been flipped. Okay, so it's been reflected about the y-axis, and it's now a frown sort of face, so the orientation's the other way. We've still got a y-axis intercept. Let's just try and zoom in a bit. Got a y-axis intercept, we've got some x-intercepts, and we've got a turning point, same as before. Okay, so let's list these features. Okay, so the first feature is the orientation. The orientation. In other words, is it going to be a smiley face or a sad face, to use the technical terms? Okay, the second feature that we've got is the turning point. Turning point. And sometimes I'm just going to call that the TP, turning point. Okay, third feature we had was, let's say, the y-intercept. Y-intercept, and the fourth feature we have is the x-intercepts. Okay, orientation, turning point, y-intercepts, and x-intercepts. Now notice here we've got only one y-intercept, but two x-intercepts. Here, similar thing, one y-intercept, two x-intercepts. Here we only had one x-intercept and one y-intercept. And let me just draw you one more graph of x squared plus, 6. There it is. So here we've got 0 x-intercepts and 1 y-intercept. So we've always got one y-intercept. With x-intercepts, we could have none of them, we could have one of them, or we could have two of them. Y-intercepts, we've only ever got one y-intercept. And only one turning point for that matter. Okay, so now what we're going to do is look at the quadratic forms. These are the features of a parabola that we've got here. Now we're going to look at the quadratic forms, and I'm going to explain why they are so important. So, quadratic forms. The first one you've seen before, it's the expanded form. Expanded form. And the expanded form is basically just a polynomial form as well. So it's whenever it looks like ax squared plus bx plus c. I might even write y equals. Okay, so y equals ax squared, so some coefficient a, x squared plus bx plus c. And you can write any quadratic in that form, the expanded form. Now something handy about this expanded form is what happens if x equals 0. So if you put x equals 0 in here, so if we put x equals 0, then we've got y equals, now x squared will be 0 squared, which is 0, so that term cancels out. B times 0 is 0, so y equals c. So when x is 0, y equals c. And if we look over here, the point at which x is equal to 0 is always the y-intercept. So, let's get some of our other graphs. So even here, when x is 0, it's the y-intercept. So, expanded form is really handy for finding the y-intercept. So expanded form is really good for the y-intercept. Because the y-intercept is equal to c. Let's use another color. So this here is the y-intercept in expanded form. Expanded form is also helpful for this first point, the orientation. Because the orientation is actually the sign of A. If A is positive, it's a smiley face. So if A is positive, we've got smiley face, and if A is negative, it's inverted, or it's been reflected in the x-axis, so it's a frown face. Okay, so that's the first form. Second form, we will call turning point form. Turning point form. Now some people also call this vertex form. Vertex form. And the turning point is the same thing as the vertex. It's just another name for this point here, the turning point. So, no points for guessing what the turning point form is handy at finding. It is handy at finding the turning point. And the form looks like this. Y equals ax minus d squared plus, whoops, I'm using the wrong symbols here. Let me just pause this video. Alright, let me start that again. The turning point or vertex form is y equals a multiplied by x minus k all squared plus h. Okay, so there's the turning point form. Now, I've used a because that a is actually, this a here is the same value as this a over here in expanded form. Same value. And that means that a can also be used for determining the orientation. Okay, the other more important thing about turning point form is that it shows the turning point using these parameters k and h. So the turning point is actually at, turning point is at the point k, h. In other words, the turning point has moved to, let me show this quickly. So if that's our little set of axes, then this point here would be k, and make sure you've got minus k there, so it's k, and this bit here is h. So we traditionally use h there because it's kind of like the height, if you like. Turning point goes up that much, and k is just an arbitrary sort of variable, I suppose. So there's turning point form. Now let's get our final form. Okay, so our third and final form that we use is factorized form. Factorized form. And if we look over at the things we've done, yes, we've found orientation, we know how to do turning point, we know how to do y-intercept. So factorized form, no surprises, is the one that's going to give us our x-intercepts. So factorized form looks like this. Y equals a times x minus d times x minus e. So there we go, there's our factorized form, and once again I've used a because it's the same a as this one, and it will once again tell us the orientation. Notice it's the only a if there's nothing in front of either of these x's here. There's nothing there. Okay, and the other thing that's useful is finding the x-intercepts. So we have x-intercepts at x equals d and x equals e. So this value and this value are our x-intercepts, and that just comes from the null factor law. Now you may be curious as to how we can convert between these different forms, and it's reasonably easy. Let me select a color. Okay, so to get from expanded form into turning point form, you use completing the square. So complete the square. To do that, from expanded to turning point form, and then to get from turning point form into factorized form, we use difference of perfect squares. Now, if you are unable to use difference of perfect squares, that means there are no x-intercepts. Now, if you want to get from turning point form back to expanded form, or from factorized form to expanded form, you can do that too. All you've got to do is expand. Okay, so just your usual sort of expansion. So you just expand the brackets and you'll get back to expanded form. So there you go. It's quite easy to get between these three very, very useful forms. So to be able to plot a parabola, all you need to do is be able to go between these three different forms and put all of these different points in. So I'm going to perhaps I'll do an example of that now. Okay, so let's do an example of this. Let's do the example. Let's plot y equals x squared plus 4x minus 3. Okay, x squared plus 4x minus 3. Now the first thing I note is that I've got minus 3 here. This is in expanded form. So it's in expanded form. So because it's in expanded form, I look to this value here, which is just a positive 1. There's a hidden positive 1 there. So because it's positive, it's bigger than 0, so I know that it's going to be a bit of a smiley face sort of look. So it's positive orientation, smiley face sort of look. Also look to this last bit, the c, the constant c there, and that is the y-intercept. So I know that it's also got a y-intercept of negative 3. So there we go, I know a couple of things already. Now, to get it from expanded form to turning point form, I'm going to complete the square. Let me completing the square. So, to complete the square, write it as y equals x squared plus 2 times 2x. Now, whatever this 2 is, we need to square it, which is, or whatever's in this brackets, we need to square, so that's 4. So we would have liked a plus 4 here, because now all that stuff is a perfect square. Now we've got to take away that 4, and we've also got to subtract this 3. There we go. So all of this stuff here is a perfect square with with a plus 2 going on inside the brackets. So refer to the previous video if you've forgotten that. And we've still got the minus 4 minus 3, which is minus 7. So we've got y equals x plus 2 squared minus 7. Now, you see that this is not quite in turning point form because we need a minus k squared here. So to get that, I know that plus 2 is actually the same as minus negative 2. Okay, so now it is in turning point form. And from this, we know that the turning point is at KH. So, in our case, the turning point is at negative 2, negative 7. There we go, turning point at negative 2, negative 7. Now we've only got one thing to do. We've got to find the x-intercepts. We found the orientation, the turning point, the y-intercept. Now let's find the x-intercepts. And there could be either 0, 1, or 2 of those. Okay, so we know to get from this, which is turning point form, or I'm actually just going to use that one from before. From turning point form, to get to factorized form, we use difference of perfect squares. Difference of perfect squares in green there. Okay, so let's use our difference of perfect squares. I'm running out of space here. Difference of perfect squares here. So far we've got y equals x plus 2 squared. Now we've got minus 7, but 7's not a perfect square, so we've got to change it to the square root of 7 squared. Now it is a perfect square, and it's a negative sign, so it is a difference of perfect squares. So we use our difference of perfect squares formula, which is x plus 2 plus square root of 7 times x plus 2 minus the square root of 7. So now we can find our x-intercepts. So our x-intercepts are at x equals minus 2 minus root 7, or x equals minus 2 plus, sorry that's a bad 2, minus 2 plus the square root of 7. So there we go. Now we've got all of our pieces of information. We've got our x-intercepts here, turning point here, orientation there, and y-intercept there. So we're now ready to sketch a graph. Okay, so first thing we do is put some labels on our axes. That's the y-axis, the x-axis. Okay, now we'll plot our different points. So the y-intercept is at minus 3, so that's going to be down here somewhere, minus 3. Turning point is at minus 2, minus 7. Whoa. Somewhere here, minus 2, minus 7 for that point. Or we could also write like this, minus 7, minus 2. You can start to see how bad my graph is, but that's okay. And our x-intercepts, minus 2 minus root 7. So that's going to be quite a bit negative. And minus 2 plus root 7. So that's actually in the positives because the square root of 7 is larger than 2, but it's smaller than 3. because the square root of 9 is 3. So that's going to be between the value of 1 and 2. So we can write that kind of like this. Oh, hang on, it's going to be between 0 and 1. So if that's a 1 there, we can sort of put this in as minus 2 plus root 7. Minus 2 minus root 7, well, that's going to be between minus 4 and minus 5. So it's going to be over here somewhere. Minus 5, minus 4, and this point here can be our minus 2 minus root 7. So, smiley face sort of look. Whoops. Let me use black instead. Well, cut through that point there, cut through the y-intercept, and through that point there. So there's an extremely poorly drawn parabola. Now let's check to see if that's correct. So we'll go back to our original equation, and I'm going to plot that using the CAS calculator. So I'll just pop that over to the side there. Trusty CAS. Alright, so let's see, we've got x squared plus 4x minus 3. Alright. So here is our graph. Now, it looks fairly similar. Obviously, mine's wonky and terrible. But in terms of the general vibe of it, it looks pretty similar. We've got this point in the right position here. And this clearly goes through 3. So let's use the calculator to first confirm the turning point and then also to confirm the intercepts there. So we'll go into menu. Let's analyze the graph. It's a minimum. The turning point is a minimum, so we'll find the minimum lower bound here. So we need to, there we go. And here's our turning point there, minus 2, minus 7. Now we'll find our intercepts. So that's the same as finding the zeros. Analyze graph. Zeros. Find that one. There we go. And we will find the other one too. There we go. Now it would be nice to confirm to see if this exact value is the same as these values here. But I'll let you do that in your own time, because it's always better to put the exact values compared to these values. So there we go. There are the main bits about sketching graphs. And I'll give you some more graph sketching hints in the next video. See you later.